Michigan's bridges have a big job to do. Besides bearing the usual heavy traffic loads, bridges here must also endure fluctuating temperatures and a range of environmental conditions. Everything from dry, hot summers to long, cold winters, and lots of freezing and thawing in between. These extremes are naturally tough on concrete, causing tiny cracks to form where water and de-icing chemicals can infiltrate. For a bridge with steel reinforcement susceptible to corrosion, that can mean a shortened lifespan and early repair and replacement. In light of these challenges, MDOT changed its approach and began to reevaluate every aspect of bridge design and construction, including the materials it had been relying on for decades. The goal? To build a bridge that will last 100 years with only minor maintenance.
About 2009, 2010, that's when we started the design of our first bridge using carbon fiber strands or carbon fiber tendons as primary load carrying members.
Carbon Fiber Reinforced Polymer, or CFRP, is strong like steel and can provide similar support to the bridge's structure. It can be manufactured into cables of varying thicknesses and added to the bridge where steel would traditionally be used. What it doesn't have, however, are steel's limitations.
When we look at how bridges deteriorate, whenever you see concrete that has spalled, it's typically because moisture has gotten to the rebar begins to corrode and expand volumetrically, which puts an outward force onto the concrete, which eventually causes the concrete to spall off. That is not a phenomenon that is experienced by carbon fiber. Carbon fiber is it's non-corrosive, so you have an element that's just as strong as steel, and it doesn't corrode like steel. And so that is how it actually behaves superior to steel in certain applications.
Michigan is recognized as a national leader in CFRP research. In fact, the first bridge in the country to be reinforced with CFRP was built in Michigan in 2001. But MDOT wanted to take the research further to understand how CFRP would last long-term under extreme stress. Working closely with Lawrence Technological University in Michigan, MDOT commissioned a groundbreaking 4-year study on 0.6-inch diameter strands of CFRP.
We built beams and we tested them to failure. We tested them in an environmental chamber at extreme temperatures below zero. We tested them in a fire chamber at extreme temperatures that would cause collapse. So we really did all of the mechanical and structural and environmental testing on these 0.6-inch diameter strands to show that we could substitute those for traditional steel strands in pre-stressed concrete beam bridges.
The efforts paid off. Using the data collected, MDOT developed more detailed specifications that make designing with CFRP easier.
So having that as a tool for our designers to use, if we wanted to do a quick comparison of, I could do this beam at this depth with carbon fiber, or I could do this beam at this depth with steel, that gives our designers a lot of options to select the safest and most economically feasible design.
The project even won a prestigious national award in 2020. Now with more than 10 bridges already built in Michigan using CFRP components and an average of 2 more added each year, as well as 6 research projects on the subject, MDOT's role as a leader in this area of study has been solidified. Backed by other states interested in learning more, MDOT is continuing the research, testing thicker strands of CFRP using many of the same tests as before to develop all new specifications for new bridge designs.
The 0.7-inch diameter strand is a larger strand, which means we could put more force into it. And the ultimate objective is to have fewer strands in a beam. So if you needed a certain force that required 30 0.6-inch diameter strands, well, you would need anywhere from 23 to 25 0.7-inch diameter strands. And when you're talking about beams that are 100 feet long and you have that many strands, there's some significant cost savings that can be realized. And we really feel that that'll be a game changer, because that is really a one-to-one replacement, the steel strand to carbon fiber strand.
While CFRP outperforms steel in many ways, it costs more upfront. But if using it means eliminating bridge repairs for 75 or even 100 years, MDOT says the initial expense will be worth it in the long run.
To my generation now that is designing and building these things, we may not necessarily see the benefits. It'll be subsequent generations that don't have to deal with rehabbing and replacing these bridges until much later in their service life.
For more information, please visit Michigan DOT's website.